చదువులమ్మ నేరుగా ప్రతి ఇంటి గడప చేరగా మీ భవితకే భరోసా దూరదర్శన్ వేదికగా తెలంగాణ రాష్ట్ర ప్రభుత్వ సహకారాలే ఉండగా హాయిగా మన చదువులు షురు అదే డిజిటల్ గురు అదే డిజిటల్ గురు.
Now let us study about the LCR circuit, how it plays an important role in communication system. Now, just now as I discussed, the voltage in LCR circuit is V is equal to Vm sin omega t and current Im sin omega t plus phi. And here we got the maximum current value, maximum current Im value as Vm by Z. That is nothing but Vm by root of R square plus. This is what just now we studied in an LCR circuit. So, what is the phenomenon of resonance? Just recollect the phenomenon of resonance. In first year, you studied in simple harmonic motion about this phenomenon of resonance. Suppose a child is swinging in a swing, and suppose we are pulling the swing. Every swing has a natural frequency. It is just like simple pendulum. Simple pendulum has a frequency. Its time period is 2 pi root L by G. Frequency is 1 by time period. 1 by 2 pi root of G by L. That is the frequency of simple pendulum. Like that, swing has a particular frequency. Suppose if you are pulling the swing, if the pull frequency is equal to the natural frequency of the swing, if the pull frequency is equal to the natural frequency of the swing, what happens? Then the amplitude of the swing will increase. So you are pushing or pulling the swing, suppose. At the same frequency, if your pull or push is there, your pull or push is there at the same frequency, then you can find the amplitude of swing will be increasing. That is what the phenomenon of resonance. Here in LCR circuit, also it has a frequency. Here this is omega is angular frequency, voltage frequency, angular frequency omega is 2 pi of course. So here the current is maximum like this. Now let us see here if XC is equal to XL. You know XC value. XC value is what? XC value is omega 1 by omega C. XL value is omega L. If you vary this omega, that means vary the angular frequency. If you vary the angular frequency, కోణీయ పౌనఃపున్యాన్ని గనక మారుస్తూ ఉంటే కోణీయ పౌనఃపున్యం ఎట్లా మారుతుంది? ఫ్రీక్వెన్సీ మారితే కోణీయ పౌనఃపున్యం మారుతుంది. ఫ్రీక్వెన్సీ ఆఫ్ సర్క్యూట్ అంటే మనం ఇచ్చినటువంటి ఎల్సిఆర్ సర్క్యూట్ లో ఇక్కడ ఇలా ఇచ్చాం ఇంతకుముందు మీ సర్క్యూట్. ఒకసారి మళ్ళీ గీస్తాను. ఇది AC జనకం. This is AC source. You can change the frequency of the AC source. You are changing the frequency of AC source, thereby you are changing omega. If you are changing omega at a particular omega value, let it be omega naught. Then XC and XL can be equal. At a particular angular frequency omega is equal to omega naught. XC and XL will be equal. So what happens at that time? We will see it here. 1 by omega c is equal to 1 by omega L. So omega square is 1 by LC. So omega is 1 by root LC. But omega is 2 pi nu, already you know. Then omega is equal to omega naught, because we have put omega naught. Let me write omega naught here. Omega naught. 2 by nu naught is equal to 1 by root LC. Thereby nu naught will be equal to 1 by 2 pi root of LC. So we arrived at a frequency nu naught. This is the natural frequency of the LCR circuit, and this nu naught is called resonant frequency. Resonant frequency. Anunada Paunaf Punyam. Anunada Paunaf Punyam. Resonant frequency. So this LCR circuit has a resonant frequency 1 by 2 pi root LC. That means the resonant frequency depends on the inductance value and the capacitance value. If you vary capacitance, if you vary inductance, then resonant frequency also varies. So you can create circuits of various resonant frequencies by varying these values. Normally, it is easy to change the capacitance value. We have variable capacitors. We can have variable capacitors represented like this. So by connecting a variable capacitor, by changing the capacitance, you can vary the resonant frequency of the circuit. Resonant frequency. So at resonant frequency, what happens to the current value? Let us see, Im. That becomes maximum. How? See, this part becomes 0. Xc is equal to XL means this part becomes 0. So Im becomes Vm by R. That means the denominator part has the lowest value. The lowest value is simply R. Other values are high. So the lowest value is R. That means Im is maximum. So resonance means current becomes maximum there. So at resonant frequency, I can write Im value at resonant frequency. The maximum current value, I represent Im max like this. It is Vm by R. How it became Vm by R? At resonance, Xc becomes XL. This part becomes 0. Vm by root R square becomes Vm by R. This is the maximum current. You can represent graphically also. Graphically also you can represent like this. This is current value versus Im value versus this angular frequency. Or frequency also you can take. Frequency or angular, anyone you can take. This becomes F naught. At this frequency, or angular frequency, maximum current will be possible. Im max will be possible. So that means in the circuit, LCR circuit, maximum current will be there when Xc becomes XL. Xc becomes XL, the maximum current will be there. That current flowing through the resistor will dissipate energy. Energy is dissipated. So if you carefully observe in an LCR circuit, we got the current value Im as Vm by Z. We derived it Vm by Z. Z is this value. Whenever if you vary omega, angular frequency of the source, carefully if you change the angular frequency or frequency of the source, at a particular frequency or angular frequency like this, you will get Xc is equal to XL. Thereby you are getting a frequency nu naught 1 by 2 pi root LC. That is called resonant frequency. Now how this principle is used in the tuning circuit? Just if you carefully observe, you can understand this. I'll explain you. Now, from the TV stations, signals are sent through electromagnetic waves and they reach the antenna in our house. So let it be antenna. So all the waves, different types of waves, they're all electromagnetic waves carrying the signals. They pass through this antenna. All these electromagnetic waves and signals, they are nothing but ACs, alternating currents. So they are all alternating currents passing through the antenna. They are all sent through the antenna into our TV. So here, the LCR circuit will be there. This is LCR circuit. Each wave is like a voltage source. Each wave is like a voltage source. So these are all the voltage sources here. So each wave in this is like a voltage source, just like this. You can compare. This is the voltage source. So each wave behaves like voltage source. Resistor, capacitor, inductor. Resistor, capacitor, inductor. This is a variable capacitor. Variable capacitor. So in our TV, when we change the channels, we rotate a button or we press the remote button. When you press the remote button, actually you are changing the capacity. You are changing the capacity. So as you change capacity, you will get a particular frequency. Suppose ETV is there. ETV waves will have some frequency. So when you change this capacity to get the ETV wave frequency, that frequency is attained by this circuit. So this frequency will match with the frequency of the ETV wave. Then there will be resonance. That means what happens? All these waves create currents in this. All these waves passing through this inductor will create currents in this. They induce currents. In all these currents, the one having the resonant frequency, will produce maximum current in this. Maximum current. That maximum current is fed to the TV, and TV will process that, and we will see the picture of the particular channel. So all the waves passing through the antenna here, they induce currents in this LCR circuit, but the one matching with this frequency, the one wave which is having this frequency, 2 pi root LC, that will create maximum current in this. The maximum current is created by that particular frequency wave. So those waves only will have high current and high voltages. Those are processed, and that signal only will be shown in our TV. This is the way LCR circuits are helpful in tuning our radios and TV. Now, I shall explain you about a concept called power factor. సామర్థ్య కారకము. Power factor means samarthya karakamu. Let us derive the equation for the power factor. In LCR circuit, just now we derived the equations for current and voltage. V is equal to Vm sin omega t is the voltage equation. I is equal to Im sin omega t plus phi is the equation. So where Im is equal to, we got it as Vm by Z. Z is impedance, the total resistance of circuit, and phi or tan phi is equal to Xc minus XL by R. These are the equations we derived in the case of LCR circuit. Now, in LCR circuit, what is the instantaneous power delivered to the circuit? Instantaneous power. We know the equation for power. P is equal to Vi. This is the equation for power. P is Vi is the equation for power. So by multiplying voltage and current, we can get power. సామర్థ్యం అంటే ఏసీ వోల్టేజ్ ఏసీ విద్యుత్ ప్రవాహాన్ని యొక్క లబ్ధం వాటి యొక్క లబ్ధము సామర్థ్యం అవుతుంది. సో విఐ. సో వాట్ ఈస్ వి? విఎం sin omega t. What is I? I am sin omega t plus y. So we can multiply Vm, Im, take them out, constant terms. So P is equal to Vm, Im sin omega t. Expand that. Sin omega t plus y. This is a trigonometric relation. Sin omega t plus y is like sin a plus b. Sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b. So apply the relation. What do you get? Sin omega t cos y plus cos omega t sin y. So if you apply the relation sin a cos b plus cos a sin b, you get this. So expand this once again. This Vm Im sin square omega t cos y plus sin omega t cos y is cos omega t sin y. Sin omega t cos omega t into sin. This is the equation. So Vm Im, this is common term. But this part we can write. There is a relation sin 2 theta is 2 sin theta cos theta. So I can write this equation as what? 2 sin omega t by 2. I can write this part as like this. So the next step I write it as P is equal to Vm Im sin square omega t cos y plus 2 sin 2 theta 2 omega t 2 sin 2 omega t by 2 sin phi. Here this is sin 2 theta is 2 sin theta cos theta. As 2 is not there, I divide with 2 and this 2 will go inside. Sin 2 omega t is 2 sin omega t cos omega t. So as 2 is not there, I divide with 2. That is the equation. This is what instantaneous power in LCR circuit. So what is the average power in one cycle? The average power. In one cycle, if you take it, that can be written as capital P or like this, or P bar or P or like this. This is nothing but Vm Im sin square omega t cos y plus Vm Im sin 2 omega t sin phi. Like that we can write. So you already know the average of sin square omega t. We already proved its value to be half. And we proved this value of sin 2 omega t as 0. In the earlier classes, I explained you how to get this value of half as 0. So substitute these values here. You get P is equal to Vm Im. This average of sin square cos y, you take it out. The average of sin square omega t, this sin square over half, it becomes half. Plus Vm Im by 2, the average of this part will be 0. 0. So ultimately you get P is equal to Vm by 2 cos y. You can further simplify and write it as Vm by root 2 into Im by root 2, because 2 can be written as root 2 square. So root 2 into root 2 is 2. So ultimately what I got, P is equal to Vm by root 2 is called RMS value of the voltage. Vm by root 2 already it was given to you as RMS value of voltage, which you can express as VRMS or simply V. V or VRMS, and Im by root 2 is RMS value of current. RMS value of current. RMS విద్యుత్ ప్రవాహం యొక్క RMS విలువ ఇది, ఈ వోల్టేజ్ యొక్క RMS విలువ. వీటిని క్యాపిటల్ లెటర్స్ తో V అండ్ I గా సూచిస్తాం, లేదా ఇలా సూచించవచ్చు VRMS, IRMS, cos y. ఇలా సూచించాలి. You can represent as you like. V, capital V or VRMS, capital I or IRMS. They represent RMS values of currents and voltages. So, power in an AC circuit, general equation for power is VI cos y. The general equation in any AC circuit is VI cos y. Let us analyze this equation. Suppose if you take a purely resistive circuit, that means only resistance is there. Already you know, in a resistive circuit, the phase difference between V and I, voltage and current, is 0. In resistive circuit, the phase difference between voltage of the source and current in the circuit is 0. That you know. So, in a pure resistive circuit, phi will be 0, cos 0 is 1, the power is VI. Pure resistive circuit. I can write it here. Now this equation, once again you see P is VI cos y, VRMS. Actually this cos y is called power factor. ఇంతకుముందు చెప్పినట్టుగా సామర్థ్య కారకము. cos y ని పవర్ ఫ్యాక్టర్ అంటాం. ఇన్ ప్యూర్ రెసిస్టివ్ సర్క్యూట్ లో అంటే నిరోధకం మాత్రమే ఉన్నటువంటి వలయంలో మనం చదువుకున్నాం phi 0 cos y 1 power is VI. అంటే మాక్సిమం పవర్ డిసిపేట్ అవుతుంది resistive circuit, maximum power. Suppose if you take an inductive or capacitive circuit, you already know in an inductive circuit, in an inductor otherwise, what is the phase difference between voltage and current? Pi by 2. Capacitor, what is the phase difference? Pi by 2. So you know that in capacitor circuit or inductor circuit, you have phase difference pi by 2. So, if you take pi by 2, what happens to the power factor? Cos pi by 2 becomes 0 and P becomes 0. So, I write it like this here. So, if you talk about purely inductive or purely capacitive circuit, what happens to the power? 0. No power is dissipated. Current will be flowing in the circuit. Current is flowing in the circuit, but there is no power. There is no power loss. Then that type of current is called wattless current. It is called what? Wattless current. Wattless current. This is an important question. What is wattless current? We can define it in a simple way in circuit. Having only inductance or only capacitor, the power factor becomes 0 and thereby the power will be 0. At that time, whatever current is flowing in the circuit is called wattless current. So, whenever the power dissipated by AC circuit is 0, whenever power dissipated by AC circuit is 0, that happens when there is inductor or capacitor. That current in the circuit is called wattless current. That current circuit is called wattless current. And another thing, in resonance, when LCR circuit is in resonance, when it is in resonance, what about the phi value? Phi value becomes 0 and cos phi maximum 1, phase Vi. So then also power is dissipated. Just now I explained you how the TV antenna works. There I showed. Across the resistance, maximum power is dissipated. So whenever the LCR circuit is in resonance, cos phi factor becomes 1, power is maximum. This is what power factor cos phi.